We want to solve this equation on the interval 0 to 2 pi. It's already in factored form, so when things multiply together to equal 0, then one of those things has to be 0. So step 1, we want to set each piece, each factor equal to 0. So I have my cosine of x equal to 0 and the 2 sine x minus 1 is 0. The next thing we want to do is get the trig function by itself. This one, the trig function is already by itself, but for this one, I need to add 1 and then divide by 2. All right, so I have the sine of x equals 1/2. Now I'm gonna overwhelm you with some information over here. Okay, so I've got, a little bit of my unit circle drawn, and remember that cosine of x, this is an angle measure, so this is, and all points on the unit circle are cosine of an angle comma sine of an angle. So this is saying what angle measure or measures has an x coordinate of 0. So looking at our unit circle, at both pi over 2 and 3 pi over 2, our x coordinates are 0. So we have those two angles. Okay, this one right here, sine, this is saying what angle measure has a y coordinate of 1/2, and that happens here and here, which is specifically 5 pi over 6 and pi over 6. So my solutions on the interval 0 to 2 pi are these 4 angle measures. Okay, then let's take a look at one that has cotangent in it. We're starting off exactly the same. I've already done the first step. When I have two things multiplied together equal to 0, we're gonna set each piece equal to 0. Then we want to get the trig function by itself, but I personally don't care to work with secant, cosecant, or cotangent. I use the reciprocal identities to turn them into sine, cosine, and tangent. Just a quick reminder, sines reciprocal, sine and cosecant, cosine and secant, tangent and cotangent. So I'm still going to get the trig function by itself. In this one, I want to add root 3 and divide by 3. But then I want to turn it into tangent. And to turn this into tangent, again, reciprocal just means the answers are flipped over. So this one, I'll do the easy one first. When I flip this one over here, I have 3 over root 3, and notice I turned it into tangent. I don't like a square root in the denominator, so to rationalize that, I should multiply the top and bottom by the square root of 3. When you do that, I get 3 root 3, and then root 3 times root 3 is 3. So 3 root 3 over 3, the 3's cancel, and I get just root 3. Now this one's a little trickier. When I go to the reciprocal, like what's the reciprocal of 0? Well, think of any fraction that has an answer of 0, like 0 over 5, 0 over 9, 0 over any number is equal to 0. So if I turn that into, say, just randomly 0 over 5, the reciprocal of 0 over 5 is 5 over 0. It's undefined. The reciprocal of 0 is undefined, and the reciprocal of undefined is 0. Okay, so I'm turning that into tangent by taking the reciprocal. Okay, when it comes to the tangent, what we're looking for on our unit circle, tangent, yes, it's the y coordinate divided by the x coordinate. And when we get to like the specifics, I might want to take the y divided by the x and see if it's undefined, and take the y divided by the x and see if it equals square root of 3. But I don't want to have to go to my unit circle and divide every single y by x to look for these answers. So it's important to remember that tangent is slope. So we're looking at our unit circle for where's the slope undefined. And we're looking on our unit circle to see where is the slope, the square root of 3. Now I think roots are kind of hard to think about, so I just grab my calculator and put an approximation. So I'm looking for on the unit circle where the slope is more than 1. Okay, so overwhelming you with a little information on the side here. Whoops. I end up with notice, I'll put that down for a second. Okay, so notice that I have right here, the purple one, my slope is undefined, and then down here my slope is undefined, and that's happening at pi over 2 and 3 pi over 2. So the answer to this one is pi over 2 and 3 pi over 2. Now you can verify that if you'd like to think of it instead of slope, thinking of it as y coordinate divided by x coordinate. I can do 1 divided by 0 and it's undefined. Negative 1 divided by 0 is undefined. Okay, then solving this one, looking on my graph for where is the slope 1.7, specifically a little more than 1. Well, if we have a positive slope, we know that our eyes have to go uphill and not downhill. Everything in quadrant 2 is downhill, so it's not there. Everything in quadrant 4 is downhill, so it's not there. So the slopes are positive in quadrants 1 and in quadrants 3. And at the 45-degree angle, the slope is 1, and our slope is 1.7. So it's a little bit steeper, so it's going to be that one. And if this has a slope of square root of 3, then that has a slope of a square root of 3. Now you can verify, if I take the square root of 3 over 2 divided by 1/2, I get root 3. But my method for tangent is, instead of going around and looking to see what every y divided by x is equal to, I just think of it in terms of slope to narrow it down. So long story short, there is my solution is pi over 3 and 4 pi over 3. And so all 4 of these angles are the solutions to our original equation.